And in permutations, on the page before it, we can actually go to the page before it. They give you a formula that you will almost never use, very rarely. It's on your formula sheet and everything. It's right here, the permutations of different objects formula. That NPR, which is the formula for permutations, is equal to n factorial over n minus r factorial. And this formula is on your formula sheet, but you will rarely use it because you can solve everything with spaces and decisions. So here's an example that could use the permutations formula, but we're first going to do it logically using what we already know. If 8 students are competing in a race, how many ways could they finish first, second, and third? Well, there's basically 3 decisions being made here. Who's going to come in first? Who's going to come in second? And who's going to come in third? And how many choices do you have for first place? Anybody of the 8 could finish in first, right? Even the slowest person. The race starts, lightning hits 7 people. That person wins. Could happen. Unlikely, but possible. Then somebody else has to come in second, right? Not very often in a race, the person runs, gets first place, runs back to the beginning, runs again, and manages to also come in second. And then 6 choices for third. You'd multiply those together, and we already figured out this math from the beginning, to be 336. Now, according to the permutations formula, this is, you have 8 objects, in this case the objects are people, and you are placing or doing permutations with 3 of them. According to the formula, this would be 8p3, and the formula says it's equal to 8 factorial over 8 minus 3 factorial, which would be 8 factorial over 5 factorial. And this is connected to what we did right at the beginning. Right at the beginning, well, what does 8 factorial mean? It means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And what does 5 factorial mean? It means 5 times 4 times 3 times 2 times 1, and a bunch of things would have canceled out. And you would just be left with 8 times 7 times 6, which is the same as your spaces, your decisions, and choices in them. Now, if you can write it all out like that, but if you had to do math with something like, let's do 10 factorial over 8 factorial, if you had to do that, I don't want you to write 10 all the way down to 1. Can you see that it would be enough to go, well, this is 10 times 9, and then at 8, I could just say it's going to keep on going. Those would cancel out, and I'd just be left with 10 times 9, so this is equal to 9. So we can use our permutations formula if we want. All that it does is get us back to our decisions and spaces, which is a lot easier. But sometimes it's nice to be able to use the formula, especially if you had a lot of spaces. Let's say you had 20 spaces and you were starting with the number 40. You might not want to do that. You might instead like to do this number always represents the number of spaces. This is the number you start with. And this is on our calculator as well. So if we hit our calculator button, the same place, I can type in 40. I can hit my math button, go over to probability. Oops. Hit the math button, go over to probability. Number 2 is NPR. So I can go 40, P, 20, and it will calculate it for me. It's a huge number. So see if you can find the NPR button on your calculator. This one that we just did was 8, P5, Again, oh, AP3, sorry. 8. One that we did was AP3 against 336. See if you can find the permutations button on your calculator and how it works. Then, questions for this one are 4, 6, 7, and 8. Now we spent too much time on the puzzle, so we'll leave example 3 for tomorrow, because I always said I'd give you at least 10 minutes at the end of class to either work on your exam review or practice these questions.